Let's take a look at how we can use the complete the square method in order to solve our equations to find the value of x. If you forgot how to use how to do the complete the square method, I highly recommend you watch my previous videos explaining how to do that, because if you don't know that, this video won't make sense. I'm just going to go through how you can solve equations using this method. In case you forgot though, a brief summary is that complete the square is you rearrange your equations into this form. And once it's in this form, it's pretty much simple to solve the equation. Let's take a look at an example. X squared plus 2x minus 5 equals 0. We're going to try and solve this equation. So essentially we're trying to find the value of x. We're going to do the complete the square. So we're going to get rid of the square, divide this in 2 to give us 1, get rid of the x and squared. Square 1, and it's always a minus, remember, so minus 1, and the minus 5 just follows downwards. If you don't know what I just did, watch all 3 of my previous videos on complete the square. By the way, just a brief summary, x plus 1 squared, that's going to be x plus 1 multiplied by x plus 1. Don't be naive and do x squared plus 1 squared, that's not the answer. It's x plus 1 multiplied by x plus 1, giving us x squared, plus x plus 1. So simplify that, that's going to give us 2x plus 1, right? That's why we have the minus 1 at the end, and that's also why I said it's always going to be a minus, because we're always going to get a third digit that's not part of our original equation, and the last number just follows on downwards. Anyways, I'll just make a brief little summary. And let's continue. So once we have put this into the complete the square method, there's actually one more thing we can do. Minus 1 minus 5 simplifies to minus 6 equals 0. So now we've put it in the complete the square form. Now it's just a matter of solving the equation. So we can add 6 on both sides to give us 6 is equal to x plus 1 squared. And we can square root both sides so the inverse of squaring is square rooting, right? So square root of 6, and it's going to be plus or minus because it's the square root, right? Is going to equal x plus 1. We did the inverse on the right side, so we can get rid of the square on the left side. So x plus 1 is plus or minus root 6. Then we can minus 1 on both sides to give us our final answer of x equals minus 1 plus and minus root 6. That's going to be our final answer. Okay, let's take a look at another example. If I can open another new slide. Okay. Let's look at one example that includes fractions, just to make it a bit more challenging. So how about something like x squared plus 3x minus 3 equals 0. So we're going to do the complete the square method first, and then we can solve our equation from there. So x squared is just going to be x. Remember, the squared goes outside the brackets, so that's why we get rid of it. Plus 3x, we're going to divide the 3 by 2, so that's going to give us half. Right? Sorry, no. That's not a half. 3 divided by 2 is not half. That's 3 over 2. My bad. And the x, remember, it just when you multiply it out, the x will just come to exist. So squared, and we're going to square this number to get our digit after, to minus it. If we multiply the 2 together, we're going to get 3 terms. We need to get rid of the third term. So 3 over 2 squared is just 3 over 2 multiplied by 3 over 2, giving us 9 over 4, right? So minus 9 over 4. And then last but not least, the minus 3 just carries on down, right? And we can simplify this out. What's minus 9 over 4 minus 3? Well, let's put them into both. Let's make the denominator for both both 4. Sorry. So to become 4, it's going to be it's 3, right? So 4 times 3 is 12. So if you simplify that, that's going to become minus 3. Minus 12 minus 9 is going to give us 21, I believe. Yeah, minus 21 over 4. So this simplified is minus 21 over 4, and we can add minus 21 over 21 over 4 on both sides of the equation to get rid of the fraction on the left hand side. So minus 9 over 4 minus 3, so that's going to give us 21 over 4 is equal to x plus 3 over 2 squared, right? And then we can get rid of this square root by doing the inverse, right? So x plus 3 over 2 is going to equal the square root of 21 over 4. And it's going to be plus or minus 21 over 4. We can add 3 over 2 on both sides of the equation. So we can minus, because here it's a positive, so the inverse of positive is a minus. So minus 3 over 2 on here gets cancelled. It's going to give us minus 3 over 2 plus or minus root 21 over 4. I believe there is some simplifying we can do, because you take a look here, this is basic simplification, by the way. Root 21 over 4 is equal to writing root 21 over root 4, right? What's root 4? Just 2, right? So, and root 21 can be simplified to become... Can we simplify root 21? I don't think so. I can't think of one on the top of my head. But the bottom can definitely become 2. And when you rationalize fractions, pretty much all the time, they're going to want your answers rationalized. That just means having no surds on your denominator. And root 4 just becomes 2. So our final answer will be x equals negative 3 over 2 plus or minus root 21 over 2. Do let me know if there's a simplification of root 21. I just can't think of it off the top of my head. But if there is, obviously you can simplify that out too. Okay, let's take a look at one when the coefficient of x is not 1. For example, what if we had, I'll write it in special blue so it's crystal clear, 3x squared minus 12x equals 60. So this time the special thing is the 3. Obviously, we can't just do x minus 6 squared like we did before, because then we'd just be completely ignoring the 3. So what do we do? Well, you can make a big square bracket around this to indicate that everything in here is being multiplied by the 3. So that'll mean, and then we'll have x squared minus, but remember, we're multiplying this 3 too. So what's 12 divided by 3? That's going to give us 4, right? 4x. Okay, that's going to give us 3x squared minus 12x, right? If the number in front was, say, 6, then we would have 6x squared minus, we're going to divide 12 by 6, giving us 2x, right? Pretty easy concept. You're just basically just expanding, you're factorizing. And that's going to equal 60. Now we can use the complete the square method to simplify out this section of the equation. The 3 is going to stay the same, but we're going to have our x now. Minus, we're going to divide this by 2 again because we're going to square it. The x, remember, disappears. And this becomes the square of this, 4. And that's going to equal 60. Then last but not least, we can factorize this out and expand. 3x minus 2 squared minus 4 times 3. Don't forget, that's going to give us minus 12 is equal to 60. We can add 12 on both sides of the equation. 72 is equal to 3 brackets x minus 2 squared, right? What can we do? We can divide both sides by 3 to get rid of this 3 over here. That's going to give us x minus 2 squared is equal to 72 divided by 3. We can get rid of the square root here by doing the inverse, which is square rooting. So x minus 2 is going to give us root 72 over 3. Now root 72 over 3, believe it or not, 72 is divisible by 3. Can you believe it? 24. So we can simplify that out to become plus or minus root 24 is equal to x minus 2. And we can add 2 on both sides of the equation to give us our final answer of x equals 2 plus or minus root 24. We can actually simplify this root 24 out too. I think we can do 2 root 6. Yes, I believe so. Yeah. So 2 plus or minus 2 root 6. But you don't really need to do that. You can just keep it as this. Pretty much the same. Anyways, that would be our final answer. So it's pretty much easy when you're just trying to solve equations by using the complete the square method. You're just basically doing the complete the square method. So you're changing the form of the equation into this square form. And then from there on, you can just do the reverse of square, which is square rooting. And yeah, that's pretty much it for solving equations using this method. Thanks for watching.